Now, in this video, we are going to take up one more problem on projections of lines. We will try to analyze and discuss how to draw by using manual drawing. So the problem reads like this: a line capital AB, 65 mm long, has its end capital A, 25 mm above HP and 30 mm in front of VP. The end capital B is 45 mm above HP and 50 mm in front of VP. Draw the projections and determine its inclinations. So here, as he says, so again he has given the NDA and also the NB. So that means the NDA of 25 mm above HP and 30 mm in front of VP. The NB is 45 mm above HP and 50 mm in front of VP. So that means he has given the locus of NB both in the front view and as well as in the top view. And he has also given the true length. So initially first we will going to take up NDA 25 mm above HP and 30 mm in front of VP. So when you look from the front view, we can see the distance above HP. So that distance is seen in the vertical plane. So when you look from the front view, it is projected to see on the vertical plane. So this is 25 mm above HP. Similarly, when you look from the top view, we can see the distance in front of VP, which is 30 mm. So that distance, when it is projected, it will be on HP. So you're going to mark this point as small a and this as capital A. So when it is taken both together, then you will going to get the capital A here. And since the NB is 45 mm above HP, so you can see the NB, which is 45 mm above HP. So the distance when it is projected, it will be seen on the vertical plane. So we have this point. So this will going to be the locus of B in the front view. Similarly, 50 mm in front of VP. So the in front of VP distance, that is this distance, when you look from the top view, that image will going to fall on the horizontal plane. So thereby you will going to get the locus of B, which is 50 mm in front of VP. Then he says the true length of the line is 65 mm long. So you're going to take capital A, B1. So this line will going to be the true length, which is 65 mm long. We can see that when you look from the top view, I can see the distance, which is 30 mm in front of VP. Capital A is 30 mm in front of VP. Similarly, capital B1 also is in front of VP by 30 mm. So now the line is parallel to VP. When the line is parallel to VP, we can see the distance in then the true length in the vertical plane. So when you look from the top, when you look from the front view, we can see that A dash B1 dash is the line which will going to be in true length in the front view. So similarly, when you look from the front view, we can see the distance NDA is 25 mm above HP and B2 is also 25 mm above HP. So naturally, this line will going to be in true length, which will going to be of 65 mm. So when you look from the top view, so that image will going to fall on horizontal plane. So you will going to get small b2 here and small a here. So join a b2 and similarly a dash b1 dash. Now we need to find out the front view and top view inclinations. So to do that, so first we are going to take up initially the true length in the front view. If the line has to be true length in the front view, obviously in the top view that line should be parallel. We can see that capital A, here small a and B1 is the line which is parallel to the XY line in the top view. So that means NDA is in front of VB by 30 mm and B1 is also in front of VP by 30 mm. Therefore, the line is parallel to VP. Since the line is parallel to VP, so you are getting the true length here, which will going to be A dash B1 dash. So now with A as center, taking the radius of AB1, which is in space, is rotated till what? Till that B1 will going to cut the locus of B in the top view. Where is the locus of B in the top view? The locus of B in the top view is in front of VP by 50 mm. So that means the B1 is now it is 30 mm. Is rotated till that B1 will going to become 50 mm in front of VP. So when you look from the top view, we can see that the image which is small AB1 is rotated such that it will going to cut the locus of B in the top view here, and then you mark this point as small b, then join AB with a dark line. So that will going to be the apparent inclination with respect to VP, which is beta. Now we will going to take up how to find the true length, how to find the front view now. So to take the front view, I have to take the true length in the top view. Which is the true length in the top view? Which is capital A and which is B2, capital B2. We know that this is the true length in the top view because when you look from the front view, we can see the distance both capital A and capital B2 are equidistant from the horizontal plane. That means A is above HP by 25 mm. Therefore, B2 should also be above HP by 25 mm. So when you look from the front view, that image is projected onto the vertical plane. So you're going to get B2 dash here and we're going to get A dash here. But actually the locus of B in the front view is above HP by 45 mm. So now it is B2 which is 25 mm above HP. So you have to rotate such that B2 will going to become above HP by 45 mm. So to do that, with A as center, taking the radius of AB2 which is in space is rotated such that B2 will going to become in front of above HP by 45 mm. Once it reaches above HP by 45 mm, so that will going to cut the locus of B in the front view which is B dash, so which will going to be A dash and B dash. Since join A dash and B dash with a long dark line and they project this point from B dash and also from B, both will going to intersect at this point. So this capital B will going to be capital AB is the line which is in space, which is as shown. So this is how you will be able to analyze this problem by considering 3 dimensions. Now we will go for this thing step by step. So here first initially we will going to find the top view. So to find the top view we have to take the front view true length. So what is the front view true length? Capital AB1 is the front view true length. This is the true length because when you look from the top view we can see the distance both A and B1 is in front of VP by 30 mm. But once you want to find the top view, so with A as center taking the radius of AB1, you rotate it such that the B1 will going to become in front of VP by 50 mm, so that when you look from the top view, that B1 is here, which is AB1, which is parallel to VP. So is rotated such that B1 will going to cut the locus of B here. When it is projected, it will be in space. You are going to get capital AB. So the inclination made by the top view is beta, and the inclination made by the true length in the top view is phi. Then we need to, so here in the orthographic projection, so to find out the top view, we have to take the front view true length. So we have, this is the front view true length and this is the top view true length AB2. So now we got the locus of B in the front view and also the locus of B in the top view. So we know that this is the true length in the vertical plane, so that AB1 should be parallel to VP. A is in front of VP by 30 mm and B1 should also be in front of VP by 30 mm. Then the line is AB1 is parallel to VP. But B1 is not in front of VP by 30 mm. Instead, the distance is 50 mm in front of VP. So with A as center, taking the radius of AB1, you rotate it such that it will go into cut the locus of B here, and you mark this point as small b, join A to B with a dark line. So apparent inclination with respect to VP is beta, true inclination with respect to VP is phi. So you record the value of phi and beta. So similarly, when you take up the front view, to find out the front view, I have to take the top view true length. So you take the top view true length, which is capital A and capital B2, which is the true length in horizontal plane, because when you look from the front view, both capital A and B2 are above HP by 25 mm. When it is projected, so that projection will going to falls directly on the vertical plane, which is A dash B2 dash, which is parallel to XY line in the front view. Since it is a parallel to XY line in the front view, obviously in the top view it will going to be in true length. So that is capital AB2. So that is what I have shown here. Small AB2 is the line which is the top view true length. So to find out the front view, with capital A as center, taking the radius of AB2, which is a line, is rotated such that it will going to cut the locus of B in the front view. So capital AB2 is the top view which is in space. When it is projected, you will going to get A dash B2 dash. As I rotate capital AB2, then what happens? The image of A dash B2 dash is also start rotating till it touches that B2 dash will going to touches the locus of B in the front view, which is 45 mm above HP. So with A as center, taking the radius of AB2, which is rotated, so that B will be above HP by 45 mm. So join capital A and B, so that will going to be the line which is in space. So join here A dash B dash with a dark line. So the apparent inclination with respect to HP is alpha, and true inclination with respect to VHP is theta. So here also we can do that by considering the XY line, and here you take the top view true length, so which is top view which is in true length, which is AB2, so capital A and capital B. So since this is the line which is in true length, obviously that line should be parallel to HP, because this is the true length in HP. So since it is true length in HP, so you have to have the line parallel to HP in the corresponding front view. So A dash and B dash both are above HP by 25 mm, but actually B2 is above HP by 45 mm. So with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will going to cut the locus of B here, and join A dash B dash with a dark line. So this is the apparent inclination with respect to HP is alpha, and true inclination with respect to HP is theta. Then you measure those angles. Now this is how we can analyze this problem by considering 3D and also by step by step. Now we will going to solve the problem by using the sketchbook. First we will going to draw the XY line and mark VP and HP. Then take the distance above HP by 25 mm and below in front of VP by 30 mm. So by using scale, you measure the distance of 25 mm and draw a horizontal line. Similarly with XY, from XY you take 30 mm below XY line and you draw the vertical line and draw a horizontal line, and consider any distance. Now consider the distance from XY line, you measure 45 mm and draw a horizontal line here, and similarly from XY line you measure the distance of 50 and draw a horizontal line here. So you will going to get the above HP by 45 mm and in front of VP by 50 mm. Similarly from XY line you measure 25 mm and draw a horizontal line. Similarly from XY line you measure 30 mm below XY line and you draw a horizontal line. Then consider any point and draw a vertical line and mark this point as A dash and this as A. And here you mark this as locus of B and you mark this as locus of B. So once you get this, so you write this as capital A and this as capital A. So with A dash as center, taking the radius of 65 mm long, take the radius of 65 and cut an arc on the locus of B in the front view. Similarly with A as center, take a radius of 65 and cut an arc on the locus of B in the top view. Then join, and you mark this point as B1 dash and you mark this point as B2. Then join A dash B1 dash with little bit thicker than XY line, and join A and B2 with little bit thicker than the XY line. So now we got the true length in the front view and the true length in the top view, and you mark this, since it is a true length, you mark this as capital B and you mark this as capital B. Then you take the front view true length. So first you are going to project B1 dash. From B1 dash you draw a vertical projector till to BA and you mark this as AB1. Since this is the front view line is a true length, its corresponding top view, which is AB1, is parallel to XY. Then with A as center, taking the radius of AB1, you draw an arc such that it will going to cut the locus of B here, and you mark this point as B. Then join A to B with a dark line, and you mark this as phi and you mark this as beta. Similarly, you take the top view true length. Top view true length is AB2. Then you draw a vertical projector from B2 till to the locus of A in the front view, which is B2 dash. Then join. Then A dash is above HP by 25 mm and B2 dash is also above HP by 25 mm. Therefore, this is the true length. This is parallel to HP, so you are getting the true length. So with A dash as center, taking the radius of A dash B2 dash, you draw an arc such that it will going to cut the locus of B in the front view, and you mark this point as B dash, and then join A dash B dash with a dark line. So you denote the true inclination with respect to HP as theta, and apparent inclination with respect to HP of alpha, and true inclination with respect to VP as theta phi, and apparent inclination with respect to VP as beta. Then by using the protractor, you measure the angle of theta and phi and alpha and beta. Theta is 17.92, phi is also 17.92 degrees. when you are doing it in manual. Here in this case, it is 18 degrees. Alpha is 18.87, it is 19 degree, and beta is also 19 degree when you are doing it in manual. So this is how we will be able to find the apparent and true inclinations with respect to both HP and VP. So this is how you will be able to analyze this problem. And we can see here both the true length are coinciding, and also both B dash and so here this is because the difference in 45 and 25 is 20. Here it is 50 and 30. This difference is 20. So this is the reason why both are coinciding. Thank you.